Hi everybody. Hi everybody. This is Dr. Dado presenting completely randomized design. And now, introduction. Yeah, this is the beginning for a series of videos on designs of experiment, theory. Well, I want to, at least in this series, try to avoid the installation of additional packages into R. Because sometimes researchers will say there are problems installing that package into their version of R. And the package is not compatible with their versions of R. So I said, okay, let me just try and avoid installing additional packages into R whenever possible. That is, assumption. I'll be assuming that my audience is fully aware of the theory. I'm not actually informing you about the theory. I assume you know what the design we're talking about entails. I'm rather going to teach how to automate the statistical analysis such that when the data is large, you give it to the computer, you give it to R, and R will effectively analyze and give you results that you cannot even manually obtain. The reference, Cochrane and Cox, 1957, the experimental design. The essence for this is, I'm very conversant with this book. I've been using it to teach my DOE courses. And I have both the hard and soft copies. And that is helping in the typing of the data. When it's time to type the data, I don't have to worry. Since I have the soft copy, I'll merely pick it from there. For today's discussion, for this video, that is the data. It is on an ailment known as scab that attacks potatoes and is captured by the scab indices of samples. Okay, the treatment entails application of sulfur during this season. And there's the control, and these are the levels of application of sulfur. Well, if you want to do manual computation, you probably will go this far, getting the means for the control, for the treatments, and that's it. Then you go about getting the analysis of variance. You probably will be told that, okay, it's significant at 5% level. As such, what next? That's probably the farthest you go when you want to do manual computation. Comment. This particular data is not too large, and hence, manual computation may not be too laborious. However, with respect to this video, I intend to tell you how to give the task to R. All right. I've left the code in the presentation because I want you to look at it, study it, and fully understand so that you can reuse the code. Except that when you reuse the code, please acknowledge me at least. If you can't make me a co-author, just acknowledge me. Then the disease is scabs. I've explained this. Well, for a code as few as just these 4 lines, 4 lines, this summary is just a request for the result anyway. You will have fed the data into R. And these are for the seasons and their levels. Season level of application 4 times in the data, 4. And then the control is 8. Okay, it's all in the data. So I just wanted it to be as short as possible. Otherwise, I would have removed that. And it will have shown you the way R takes the data in data frame format. Now, this command is to tell R to create analysis of variance and to model scab carbon treatment. See, and that will give you this, giving you that indeed at 5%, that's significant. Okay. So you probably want to stop there if you are not fully aware of all other things that R can provide. See now, if you give these additional 2 codes, in fact 1, because like I said, this is to request for the results. This additional 1 code, see what happens. That single code is responsible for this. I have placed the codes and the output side by side so that you can easily see. Here, the contribution towards the significance of the treatment are shown. See, that is significant. Why is this significant? The control and these other ones are the same. In fact, nothing is treated with respect to these ones. So the actual treatment is fall at 12 level. That's the actual treatment. This is weak, but it also treats it. You'll be able to see that. Meanwhile, LM stands for linear model. You do a linear model of scars based on treatment, that's what you get. Now, if you use this additional code, just this one, you are invoking the generalized linear model then, and it will give you additional results. To give you residual deviance, it will give you the AIC. It will give you even the Fisher's scoring. So you get more times from it. And again, it's still emphasizing the fact that F12 is still the best. All right. This is the farthest I intend to go on CRD. Watch out for the competition of other designs. Please like, share, and subscribe. Thanks for listening. Bye for now, and God bless. Thank you. See you next time.